Hi, in this video we are going to cover the topic of exception, which is a very important topic related to error handling in Python. So to motivate for this topic, um, consider these two lines of code, which is very simple and we know what it's going to do, right? That, I have a variable that is a string and it's ABC, and I'm trying to convert that thing into an integer. And we know it's not possible, right? Now, so think from the perspective of maybe the programmer who's writing int, right? Int is expected to return an integer. Now, but it when int looks at the input s, and then so what is the programmer to do when s is just impossible to be converted to an integer, right? As in this case, then what should int return if it's not possible to convert the input into an integer? Is there a number that the programmer can return to indicate that the int string is not a number? I guess the answer is kind of obvious, right? Because not really, you cannot return a number to say, the input is not a number, right? You can try to, okay, what if we return 0 to indicate, the input is bad? Input is 0 is kind of a special number, right? But no, what if the input is actually the string with the number 0, right? So that's why there is a little dilemma there, right? What do we actually do to indicate that the input is not a number? And that's why, I'm sure you've seen this, when you run this piece of code, what actually happens is we see this scary red thing that says, oh, value error, right? That ABC is really an invalid integer, at least for integer with the base 10. So that's what this thing is. So pay attention to this thing, value error. Value error is what's called, it's one of the many exceptions. So what exception is? Exception is an outer band way to report an error, right, when it happens. So what I mean by outer band is that it's kind of outside the normal flow of information. Right? We normally, the way information flow from a function back to its caller is through a return statement. But exception is not quite through that same mechanism. And we'll see exactly what it means in just a few seconds. But okay, just let's get the terminology right. Okay, so a function or a method, which is the callee, the function that is being called, the callee reports an error by raising an exception. So, like you said, it's kind of like returning a result, but it's not quite. It's out of band. Okay. Now, so that's the callee. Callee's job is to report an error by raising an exception. And then the caller, whoever calls the callee, can then handle an exception. Okay, it's kind of like capturing the returning value of the callee, but again, not quite. Okay, so let's see. Well, actually, before we even do that, there's still the question of, okay, well, since something went wrong here, something's wrong, why don't we just allow the program to crash? Right? Why do we have to handle when something goes wrong, right? We just want things to go right all the time. Well, things don't go right all the time. And actually, error can happen as part of a normal program execution, right? For example, we've seen this kind of code many times already throughout the quarter in various assignments. That when we ask the user to type a number, okay, and we expect a number and we want to do some operation with that number. Now the user may just kind of happen to type the wrong thing, right? Or didn't read your prompt carefully and just happen to type a string. Sorry, something that is integer, non-digit. Right? Or maybe the user is kind of evil. There are evil users, and they just want to screw up your program, want to crash your program. So he types in something that is not a number. But either way, we really don't want to just simply crash a program. We want to give the user another chance to type the number in again, right, until he or she gets it right. That's what we usually want to do. Okay, so that's why we want to handle exceptions. All right, so how do we handle exceptions? Here is, let me show that in the code. So we know, okay, this is the line that can potentially raise an exception. Okay, so to handle the potential exception that may be raised, we put whatever block of code that may raise exception in a try block, right? So, and we do that, and normally after the string is converted to I, we can report the string is converted to an int and that thing, and we do string. The first one is a string, second one is an I. So this is, if everything goes well, if this did not raise an exception, then we keep on going to the next line, etc. Right? However, if this line somehow did raise an exception, then we can handle that exception by using the keyword except. And inside except, it's when the exception has been raised, we say, okay, let's say we fail to convert this, whatever the string, to int. Right? And we can say we fail to convert that s, whatever that s is. So let's see that it actually works normally first. So if I say 10, okay, it should work. It should not raise an exception. So I'm going to run it, and it just basically tells me, okay, it tries to do this, it successfully do it, then it comes to the next line, okay, and it prints that out, 10, the string 10 is being converted to an integer 10. All right, and then it does not do anything in the except block. Right? It doesn't, because nothing inside the try block raise any exception, so it will never come here. It will just go on to whatever the line that follows. Okay, now if we change it back to ABC, this should raise an exception, and when it raises an exception, it should come to except and do whatever in code, or execute whatever code that is inside except. So it should say fail to convert this. So let's see that doing that, and that's what it does, right? Okay, so hopefully that kind of makes sense, and that's what these slides are trying to say here. Is again, the important thing is about the try block. Whatever you put, whichever line of code that may raise an exception inside try and other lines of code, and that's okay. And then if the line does not raise any exception, it will just go through everything inside try, but it doesn't do anything in except. If, on the other hand, the line of code raises an exception, then it immediately skips everything after the line that raised the exception. So it skip, this successfully converted to int. So we don't see this line. Immediately jumps to the first line in except, and then the execution kind of just picks up from there. Okay. Another way to kind of think about this is, you can kind of think about it like a conditional if, right? If everything's good, everything's normal, then we do everything inside try, line by line by line, as usual. If there is an error with one of the lines in the try, it will jump to except and then go from there, right? Kind of like conditional, not entirely. All right, so that's another way to look at it. Couple more kind of finer or useful point with except is, actually, let me bring this up. It actually says here that it says too broad exception clause. What basically means it will because I only say except here and it doesn't exactly specify what kind of exception I want to handle. Every exception that occurs inside this try block will come here. Okay, so it's kind of it's very broad. It handles all sorts of exceptions, and that's okay sometimes, depending on what you want. Now, we know integer or int will actually raise a very specific kind of exception, and that is value error. Okay, so we can actually say, all the exceptions, we only care or we only can handle value error, right? So we can say that. So in this case, then we'll come to this except block only if a value error is raised. But that's the only thing that int raises. So that's fine. That's it doesn't make a difference here. It might make a difference in other situations. The reason I want to bring this up is this is actually even more useful. Is remember when the message that we saw earlier when the program crashed, it actually gave us a very nice descriptive message inside value error, telling us exactly what it doesn't like. So it's actually useful that way, right? And we can actually capture that error message and print it out. The way to do it is we can actually capture the exception. So exception that's raised by int is another object, is another instance. Remember, everything in Python is an object. So specifically, this will create a instance of value error, and we can capture that instance in the variable, whatever name that we want to give it. Typically, we call it E for exception or error, right? And that's just then another variable that we can use. And one of the most common use for that is we want to print out the error message that's contained inside this exception. And you can simply, not S, but E. So E, if you just simply convert it to a string, it's the error message, the descriptive, hopefully descriptive error message that's contained inside the exception. So if I run this now, that's the very descriptive error message that lives inside the exception, inside the value error exception. So that's useful. It's often useful to be able to print this out when something goes wrong. Okay, so that's, I believe, what this is. These slides are for. All right. So okay, so hopefully you kind of see how to handle the exception raised by some of these built-in functions. So here is a little exercise for you, that given this piece of code, we have a list of 3 elements. We're trying to get the 10th or the element at the index 10. Now, we know it's going to crash, right? So now 2 things you want to do. One is figure out what type of exception it raises. So if you just run this, you will see the type of exception if you read the error message carefully. And then the next thing is you really want to let's handle it. Let's not just let our program crash, but handle the exception and print out the message that's contained inside the exception. All right, so pause the video, give this a try. Okay, I actually let me do this quickly so that I didn't type this out. 1, 2, 3. And then what do we say we want to do? Oh, right, we want to print list 10. Right, we know it's going to crash. And again, you can see it's an index error, and that makes kind of perfect sense, right? This is an index, but 10 is totally out of range. The maximum index should be 2 here. So in order to capture that, we say, we put whatever code that may raise an exception in try, and then we say except we know index error, so index error SE, and then we print out the error, whatever the error may be. And I'm going to say that, and hopefully, so instead of seeing this ugly thing, and then the program crashes, I can handle it, and then the program will go on to do, there might be potentially many more things after it, so it can go on to do other things. In this case, there's none, but still, we don't want to crash and burn. So yeah, this is exactly the exception that is thrown by trying to use a bad index. All right. So another problem for you is this thing that we looked at earlier, right? We ask the user for an integer. User can give us an integer or something that is non-integer. This which will crash our program. So modify it so that it repeatedly prompts the user for an input until the user actually types an int. Then once in this the user type an int, then we can do the following. So kind of trap the user in the input until the input is an int. So give this a try.